వస్తుంది సార్.
Start, please.
Hi, how it's going on, everybody? I hope that you are well and safe at your homes. And I welcome you to the session on different types of graphs that are used to describe the data. I am K. Ramakrishna, studying 10th standard from TSWRS Boys Satapalli. So let's get started with our session. So before getting started with the session, I want to introduce the two quick words that we use frequently in the overall session. They are data and graphs. So it is a prerequisite to know about these before we start the session. So let us, I will come into the session on different types of graphs used to describe the data. So let's get started. Madam, slide please. Slide. Okay, here on the screen you will see a small statement where on the screen you will see a small statement about the information about the city AB. So in a city, 400 active cases were confirmed in a week, and half of them were cured and remaining are being medicated. But unfortunately, today quarter of the medicating people were confirmed to be dead. So here we are having some information about the COVID-19 patients in a city AB. So here from this statement, we are having some information about the city AB. So here from this statement, we can know the active corona cases in the city AB and the deaths confirmed today. And we can also know how many people are being cured or how many people are being medicated now. So this is the statement that is offering us some information about the city AB. So here normally it is giving us some information. So here this information is called the data. So normally the data is defined the set of units of information. So from this statement, we are having the information and this is called the data of that city AB. So here we are having this statement, but in this statement, there are some tricky statements that we have to understand. Because here indirectly we are saying 200 cases were confirmed, 200 cases were being cured. That means here we are using the phrase half of them were being cured. So while we are having this type of tricky sentences, then it would be hard to understand for some people. So for this, we have to look at an alternative that just represents the same data in some other forms. So really, is there any form to represent the data? So let us see what is that. So here on the slide, you will find on the right hand side, you will find the table that with the title, the COVID cases in the COVID-19 analysis in the city AB. And there you will find the table, total cases 400, deaths 50, active cases 150. So here you are knowing the same information as we have in the mathematical statement in the left hand side. So that means it is easier to plot the same statement in some other pictorial form in order to get or in order to convey the information for some people. So here we call these terms or these pictorial figures as the graphs. So this is just a little bit information about the graphs, and we will see them detailed in the session. When we're getting started with the session, we will see the details about them. So normally we use these pictorials. So here let us insert the word pictures so that we are saying we are representing the data. So here in many subjects, not only in mathematics, we use these pictures to represent the data. For example, do you know the most trending topic in the world today? That is artificial intelligence. In that AI, these graphs or these pictures are being used to represent some data. As we know that the computers all work with data. So the data should be taken in the form of pictures, and that is used there. And also in social studies, we will have some weather reports. So to represent that weather reports in a pictorial form, we use these graphs. And then here we can also see the example of the data, like if we collect some information or some marks from the students in a class, then the mark sheet will be a data of that class. So here each student will have his or her respective marks. So that is called just an information, and that all the information is named as the data. So now in this session, we are going to represent this data in some other forms in order to get the too easy of understand. So let's get started. Now here, before getting started with the session, let me introduce let me introduce the quick overview of the slides, or the quick overview of the overall session. And here is the overview. We will start with water graphs, and then we will move ahead on exploring the types of graphs, and then we also discuss how are they useful, and also we will discuss the structure of graphs. So structure of graphs is nothing but that we will explore more about how to build these graphs. So let's get started. Now here the first thing is statistical graphs. Now here, when we have the statistical graphs, you can observe the title there, that is statistical graphs. Normally, the statistics are defined as the collection, organization, analysis, and the interpretation of data. So here we use these statistical graphs to represent the statistical information. So there are some types in the statistical graphs. So overall, we have grouped some graphs to be the statistical information. So let us see what are those. So before going that, let us see the quick overview of water graphs. So normally there would be some people who have very little interest in the mathematical information. For such people, if we want to make it easier to understand that mathematical information, then there should be some representation of data to make it easier to understand. So there we use the term graph. So normally the graphs are the pictorial forms that we represent the data. And these graphs are like the animated films of the simple stories. So while we are listening the simple stories, then it is okay, we can listen, but some people might not be understood what is this, what is going on the story. So for such people, if we make the simple stories be animated, then that's look amazing and interesting to know, and that conveys the overall context of the simple stories. So the graphs are used in the same way to represent the data. So let us see the statistical graphs right now. So as I have said that these statistical graphs are used to represent the statistical information, and these might be bar graph, pie graph, and also bar graph, pie graph, and many more. So let us explore all of them. So here, first starting with bar graph. Bar graphs are used to represent the group data, and they uses the rectangular bars to represent the data. So here we use the rectangular bars to represent the data in the bar graphs. So there, the each length of the height of the bar graphs represents the value of the data. Normally, we use these bar graphs when we have uh, the situations of using the categorical data and the discrete data. So if we are having that categorical or discrete data, then we represent normally categorical data on the x-axis and discrete data on the y-axis. so that we will start plotting with the rectangular bars with the base x-axis. So there are some rules to draw these graphs, that are there should be the same width for each bar in the graph, and the difference or the distance between the two bars must be equal in all the cases. And here the height of each bar represents the value of that category. So if you observe the bar graph on your screen, then you will find the comparison between the two social media networks, Facebook and the Twitter. So to get the traffic source between them in the years 2007, 8, 9, and 10, and I have collected the information to compare them with the bar graph. So here the yellow color bars represent the Facebook and the green color bars represent the Twitter. So in 2007, we can say easily that Facebook is having the more traffic than the Twitter. So in 2007, 8, 9, and 10 also we can compare the same thing in the same way. So here we are using these large data changes over time. So it is better to use the bar graphs when there is large data changes over a period of time. So when there is large changes, it is better to use the bar graph. And these bar graphs are also used to make the frequency distribution tables easier to understand. So when we have the class intervals or the group of data, then it is better to use these bar graphs. So these bar graphs are used in many ways to analyze the data. Okay, then moving ahead, we can see the line graphs. So the line graphs uses the lines and the points to represent the data. Normally, these line graphs are used to represent the data that which is in the form of continuous. When the data is in the continuous form, we use this line graph. So let us see how can we construct these line graphs. So normally we will plot this in the on the two-dimensional plane, which has the x-axis and y-axis normally. So if you observe the graph on your screen, on the right-hand side, that is the line graph, there are some lines going up and down. So that is just representing the data. So here I have collected the information about average monthly rainfall in two imaginary cities, city 1 and city 2. After that, I am representing the average monthly rainfall in each of the months, January, February, March, and many more. So here, while I am representing, so normally x-axis is used to show the time, and y-axis is used to show the discrete values. So if you observe the yellow color line that represents the city 1, that is showing the difference between the two consecutive months. So in January, it is 1.5, and in February, it is being 2. So it is showing the difference between the both of the months. So here, when there is some change in the data over a month. So when there is a little bit change in the data over a period of time, then it is better to use line graphs. Oh, just wait. In the previous section, I have told that it is better to use the bar graphs when there is changes in the data over a period of time. But now I'm saying that it is better to use the line graphs when there is changes over a period of time in the data. Yeah. In bar graphs, it is better to use those bar graphs when there are a large change in the data or a large period of time. It is better to use that bar graph. But when there is small change in the data over a period of time, then it is better to use the line graphs. So using these line graphs, we can make the predictions. So how can we make the predictions? If we see the line graph right on your screen, then you will observe the up and downs of those lines. Just they are representing the data. When we see from the first 2 points, we can automatically predict the third point according to the category, because we are having some experience on plotting them, and we are having some analysis on our mind on how that category is upping or it is going down. So it can be better to use these in businesses where we compare the profits. And also these are used to compare different variables over a given period of time. So if there are two different variables is nothing but the discrete data or the categorical data, or if there are any some other variables, we can also use this to show or to plot that data on this line graph. And then moving ahead, we have this pie chart. So here this pie chart is used something differently. So that is not different as all these bar graphs or line graphs, but that is there we use the circles. There we use a whole circle to represent the data. So normally we will have a 360-degree circle, and in that these pie charts are used to represent the data when there is the compositional sections in the data. So to represent the compositions of something, this pie chart is used. So if you observe on the screen on your right hand side, you will find the pie chart. So there you are seeing that I have collected some information about the types of transportation to the school. There you are getting the types of transportation. There are many means of transportations like bus, auto, bicycle, and bike. Here I'm comparing all those things using this pie chart. So if we take this auto as an example, 10% people are being used this auto. So then how can we plot that? We plot that, we calculate the 10% of 360 degrees of the circle, and then we plot that angle in the pie chart, and we represent that with some color. So that is normally done in these graphs, and the uses of this pie chart is very precious, because when we have the large businesses, then if we want, we can have the profits or losses. So the profits can be taken in some ways and the losses can be borne by us in some cases. So to observe those cases, we can use this pie chart. So if there are some compositions in your profit, then we can represent that in the pie chart, and then we can get the information easily. Okay, this pie chart is being used by many of us and it is so useful. And before going to the next slide, I want to say you the tip. It is better to use some 3 to 7 categories in the pie chart, because it looks awesome, and if we increase that, it would looks clumsy. So that is the only thing that we have to bother with that pie charts. And going ahead, we have the histograms. These histograms are also the are looks like the same as the bar graphs. Histograms are also use the rectangular bars to represent the data, but this looks same as the bar graphs, but there is some difference between the bar graphs and the histograms. So let us see what are those differences. By just seeing them, we can understand the differences. What are they? While we are drawing the bar graph, then there is the space between the two consecutive bars. But in the histogram, there is no space. That means if we use that bar graphs to represent that group of data, then we use this histogram to represent the continuous data. When there is the continuous data, we use these histograms. So normally these continuous data means that when we have the class intervals in the frequency distribution table, when they are in the inclusive form, it is better to use this histogram. So how can we plot this histogram? We plot this histogram on the two-dimensional plane having x-axis and y-axis, and on the x-axis we give some category or the classes. And the main advantage of this histogram is that we can represent the data if the height of the class is different. There are the different heights of the classes. So but in the bar graphs, there is no restriction about the heights, but there should be the whole of them, the heights of all the class intervals must be the same. But here it is not to be like that. If you observe, I have collected the peoples of different ages and their salaries. So here you can observe the people's age is represented on the x-axis, and the salaries are represented on the y-axis. So here we are representing when there is data is the continuous. So here 24 to 34 is the age, and then the next age is beginning from 34 to 44. That means here 34 is being included in both of the sections. So it is better to use the histograms. And these histograms are also used to summarize the large data graphically. And these are also used to communicate the data distribution quickly to others. Of course, that is the job of all the graphs. Okay, now let's move ahead to the scatter plot. This scatter plot looks similar to the line graphs, where you will not find the lines in the scatter plot and where you will find the lines in the line graph. Scatter plot uses the points to represent the data. So we represent when we use this scatter plot when we have uh, two variables, and to show the relation between those two variables, we use this. So let us see how can we represent the data in this scatter plot. So here I have collected the information about the fictional trees. So just imagine that there are trees, and here each dot on the graph represents each tree. And here you will find on the x-axis, there is the diameter of each tree. And on the y-axis, you will find the height of each tree. So here I used this scatter plot to represent this data because I have to show some relation between the diameter of the tree and the height of the tree. So normally what we think is, or the natural thing that happens is, when there is the large diameter, then the height is also too large, because that is about the size of the trees. So normally that happens. So we are using this fictional trees data on scatter plot to show the relation between height of the tree and the diameter of the tree. So here on the, you can observe the dots. So each dot represents its individual value from the x-axis and from the y-axis. And here in this example, each dot represents the tree. And it is better to use this scatter plot when we have the paid numerical data. Okay, as we have said that it is better to use scatter plot when we have when we want to show the relationship between two variables. So here, if there is correlation, it is very nice to use scatter plot. So correlation is nothing but they two variables are the proportional to each other. If one increases, other increments, and if one decreases and other also decreases. So using this scatter plot, we can find the value of dependent variable by seeing the value of independent variable. So here dependent variable is nothing but one of the variables that we are going to use the comparison, and the dependent variable is nothing but that which someone asks us to find, and independent variable is nothing but the value that is already given. Okay, this is about the scatter plot, and now let us move ahead. Now here we can find this frequency distribution table. So normally this frequency distribution table is used all over in our day-to-day activities easily, because this frequency distribution table is used to represent the number of frequencies that are the number of classes or the number of entities that has repeated so far. So if there is an entity, the frequency distribution table is used to how many times that entity has repeated in that frequency distribution table. So normally, for example, I'm showing the marks of the students in a class, and here I have collected all the marks. So I have some data, and now I'm analyzing the data to collect the different marks obtained by the number of students. So I have listed 25 students that who have gotten the 25 marks, and then 24, 23. So I have listed all the students and the frequencies of them. So the number of students is called the frequency in this example. So here this is about the frequency distribution table, and we use this frequency distribution table to represent the statement, mathematical statement in simple form. So normally this frequency distribution table can also have the raw data, but it is the basic form that we use to represent the data. So normally in the previous slides, we have learned about the bar graphs, line graphs, and pie charts, and many more. There we use this frequency distribution table to show about the bar graphs, or to plot the line graphs. We use this frequency distribution table. And normally when we are coming with or beginning with statistics, the first graph that we are introduced is this frequency distribution table. And this frequency distribution table is plotted in the tabular form by having the classes and frequencies. Classes are nothing but the marks in this case. And frequency distribution is used to condense the data. So it is just to use to minimize the big data into the small data. So it is about the frequency distribution table. Now moving ahead, we have the exponential graphs. So these exponential graphs are used to represent the exponential functions. That means wherever we have the exponential functions used, then we have the use of these exponential graphs. So let us say, how can we represent these exponential graphs, and what are the uses of these exponential graphs in our day-to-day activities, or in the activities that all of us do. So normally these exponential graphs are also used, or these exponential graphs can also be plotted on the two-dimensional plane, which has the x-axis and y-axis normally. And if there is, in this example on the screen that you are seeing an exponential graph, and here you will observe the exponential functions on the top of that graph, that is y equals to 2 power x. Now, how can we represent this information or this function into the graphical method? So we represent this y equals to 2 power x as we will take some value for x, and we will substitute that x in the equation y equals to 2 power x. And then we will get y for each of the values of the x we substituted. So if we start at x to be 0, then 2 power 0 is nothing but 1. So y is being 1. So the first point is at 1. And if we see that 1 means in the y-axis, from the y-axis, that is the value of 1. Okay, and then moving ahead, we have that if the x is 2, or if the x is 1, then 2 power 1 is 1. 2 power 1 is 2. So here y is being 2, we have to represent the 2 on the y-axis plane. Okay, now these exponential functions can be used in many ways. These are used in population growth, pH values, in chemistry. So to calculate the pH value of a substance, we use these exponential functions. And these are also used in the radioactive decay problems. And here, the main important thing is that these are used in financial data. So more sector, it is used to calculate the compound interest. Now, just moving ahead, we have the logarithmic graphs. So logarithmic graphs are the inverse functions of the exponential functions. So if there is an exponential function, then that the inverse of that exponential function is this logarithmic function. So what is meant by inverse? So here inverse is nothing but, in simple terms, we swap the two variables that are x into y and y into x. So let us see how can we represent these logarithmic graphs. So we will have that x-axis and y-axis, and there we will substitute the values of x to get the values of y, as we have done in the previous example. So here I have taken the example y equals to log 2 to log x to the base 2. So each time I represent the value of x in this equation, I will get each value of the y. And then I will just plot this, the values of x and y on the graph, and I will put the points there. And finally, we will connect all those points using the line. So normally these can also be negative. So when we have the x in negative terms, then y would be in negative. So here you will see that y cannot be 0 in that exponential functions, or in this logarithmic function, that in the exponential functions x cannot be 0. Sorry, y cannot be 0, so that we cannot touch the whole graph on that y-axis. So it goes closer to that x-axis, but it doesn't touch. But in these logarithmic graphs, y cannot be 0. So goes towards that y-axis, but it neither touches it. So normally to represent the logarithmic graphs, we can use the view of the exponential graphs. Just we use the inverse graph. So if you look these logarithmic graphs and exponential graphs, that the exponential graph is curved upward and this logarithmic graphs will be curved lower down. Now these logarithmic graphs can be used in when we are quantifying relative change instead of absolute difference. So when we are calculating that relative change and absolute difference in those problems, we can use these logarithmic graphs. And also these are also used in the population growth in the biology. So, and these are used in many ways in our day-to-day activities. And then moving ahead, we have the trigonometric graphs. So normally, as we have seen that logarithmic functions can be plotted into the logarithmic graphs, we use these trigonometric graphs to represent the trigonometric functions. So normally we get, if we have the trigonometric function, then we substitute as same as in the view of that logarithmic graphs and the exponential graphs, and then we will start plotting the values in this. And then these trigonometric graphs are also used in various ways, where in all the cases where the trigonometric functions are being used. And on the as the example, I have taken the function y equals to sine x. So here I'm going to represent this value. So each time I put some value in x, I will get the value of y. And we will represent that x and y values to get these trigonometric graphs. So here these trigonometric graphs can be applied for all the trigonometric ratios: sine, cos, secant, cosecant, tan, and cot. So here just in an example, I have used this sine, but you can extend it for other trigonometric ratios also. And these trigonometric graphs can be used in the tuning forks when the guitars or the musical instruments are being created or producing. Then we use these tuning forks to get the tune of the music that to be released. So in that calculation, these trigonometric graphs can be used. And in the Ferris wheel, often we call this as the giant wheel. So this, while these Ferris wheel also have some trigonometric functions, so we can come across our mathematics lessons where we have the problems on this Ferris wheel. And there are also some other examples and where we can use these trigonometric graphs. So this is all about this session. In this session, we have come from many, we have come overall through many graphs, bar graph, line graph, histogram, pie chart, a scatter plot, and many more. So let us see the small cheat sheet or the flow chart of this graph, or the small cheat sheet of this session. So here is the cheat sheet on the screen. You can see the cheat sheet where you can find the whole mind map that we have coming from the start to the end of this session. So do you notice anything? This flowchart is also called itself a graph. So these graphs cannot be only used in mathematics. These can be extended in various ways. So even if you study biology, then uh, if you want to revise the whole lesson that you have learned, then you can use these flowcharts to get the view of that lesson. So these flowcharts are also called as the graphs. So here in this flowchart, you can observe the sessions where we have come from. Uh, you can observe the timeline of the sessions on this graph. So where we have started discussing about data, graphs, and then use cases of graphs, and then the types of graphs: statistical graphs, frequency graphs, exponential graphs, logarithmic graphs, and the trigonometric graphs. And you can apply all these in our day-to-day activities, and we can get easy to use the data using these graphs. So the graphs are being used by all of the people to make the data easier, and it is very important to represent the data in the form of graphs, because we are using these graphs in a well-known manner, and it is easy to plot the graphs, and we can plot all the data into the graphs to understand the data easily. So now that is about the session, and now if we can have any questions from the audience, let us listen.
Thank you, Yashoda. That was a really amazing presentation. So we have a question that can you please explain us how to frame a data table for analysis? Like if I have a lot of data, but then how do I frame them to do analysis to draw these graphs?
So normally when we are analyzing the data, when we are using the data to analyze, then we will have some key points that has to be noted. For example, if we see the example in the example I have introduced in the first thing, that is about the COVID-19 cases in various situations. So there I have used the total cases, active cases, and death. So here there are some keywords that we have to note, and that normally if we have the data, that is called the raw data, and extracting the data that we want is called analyzing the data. So while we are analyzing, we have to keep in mind what we want from this data and what sections we have to get copied from this data so that we can represent it in a easy way in the graph. Madam, simply that we should have some key points in the graph, in the data, and we can represent the key points using these graphs. And first of all, it is better to use the frequency distribution table all over.
Thank you, Yashoda. We are done.
Okay, thank you, madam. And I thank all our society and mainly our principal madam, Mr. Devajyoti madam, and the whole staff of PSWRS Boys Sattupalli. And I myself thank you for attending this session. Thank you. Be safe and be smiling.